When people hear the term catalyst synergy, their first reaction is often that the reaction becomes faster. In this episode, we focus on one key question: why does using different catalysts together lead to a clearly amplified effect? After watching, you'll understand that synergy has never been about stacking strength. In flexible PU foam systems, there is a phenomenon that appears very frequently. When two catalysts are used together, the reaction becomes smoother, the processing window becomes wider, and the system becomes more stable. This is also why many formulations perform only moderately when catalysts are used individually, yet show a noticeable overall improvement once they are combined. But here is a point that is very easy to misunderstand. Synergy does not exist because the system is being pushed harder. It exists because the catalysts act in different positions. If we look at this from an engineering perspective, the logic is actually quite simple. Amine catalysts mainly influence how the reaction starts and the timing of gas generation. Organotin catalysts mainly influence how the polymer backbone is built and how quickly the structure becomes locked. They are not pushing at the same reaction point. They act on different reaction pathways and at different stages of the process, and precisely because of this, when these two pathways are each driven properly and at the right time, foaming and gelling are easier to align, and the reaction naturally becomes more stable. If synergy is misunderstood as more strength, it often leads to one common direction, continuously increasing dosage, only to find the system becoming harder and harder to control. The problem is not the catalyst itself, but a misunderstanding of how synergy actually works. True synergy does not solve a speed problem. It solves a timing problem. But the concept of synergy only becomes meaningful when it is applied to specific catalysts. In the next episode, we will start with one of the most commonly used catalysts and make this synergy relationship concrete. See you later.